Hi everyone, this is Munir Ahmed from George Mason University. If you have worked on observational studies and analyzed data from observational study designs, you know how difficult the causal analysis is using observational studies and data from them, where the researcher does not have control on treatment variable and or how it is implemented or distributed. In this video, I will be talking about stratification to deal with confounding, which is one of the major challenges in observational studies and has been for a long time, though there are many uh, areas that are developing to address that issue in observational study design and research. Is the scenario where association between an independent variable and an outcome variable is affected or distorted by a third variable. Confounding can be positive or negative depending upon the fact that whether the association is being biased away from null or pulled towards null. Suppose we are looking at a cardiovascular disease as our outcome, and our independent variables are age and BMI, which is to say, obese and non obese. We can notice that age and cardiovascular disease are associated. Cardiovascular diseases, after all, are more common in older age, but also people are more likely to be obese as they age. This is confounding. Is the process of creating smaller homogeneous subgroups from a larger heterogeneous population, thereby keeping the shared features constant within strata. Stratification blocks the effects of third variable and hence addresses confounding in natural experiments or observational studies. This approach is called stratified covariate balancing. It is particularly useful in healthcare data where comorbidities and co-occurrences of clinical signs and patient symptoms is common. Covariate balancing creates data by identifying naturally occurring combinations of covariates in the data and then estimating the impact of independent variable on outcome variable within each strata. For binary outcomes, odd ratios are calculated using Mantel and Hansel method, and for continuous outcome variables, weights are generated that can be applied. How to conduct stratified covariate balancing. Though it can be a graduate course itself, some hints are below. Firstly, there's a very useful R package developed by folks at George Mason University. It's called Stratified Balancing package. What it package does, the authors provide a very good introduction in R package documentation, which reads package does stratified covariate balancing through naturally occurring strata to adjust for confounding and interaction terms. The package has four main functions which perform stratification and sensitivity analysis and provide adjusted odds ratio along with naturally occurring strata. This is a very user-friendly package in R and can make your life very easy in terms of doing covariate balancing if you are an R user. To install the package, you need to use the command install.packages parentheses stratified balancing close parentheses. You have to load it, for which the command is library parentheses stratified balancing close parentheses. To read your data, let's say if your data is called my data, you can use the following command, which is data is equal to read.csv parentheses my data close parentheses. Provided your data is cleaned and after selecting appropriate columns using column names command, you run the following command to balance the data. The command being new stratadisk and parentheses where column name for treatment comes first, followed by column names for outcome, and then the name of the data on which you are using this command, which in this case was my data. Let's go through the command that we used on last slide one more time. New stratadisk parentheses column name for treatment. This would be the column number for treatment. This would be the column number for treatment in your data set, and column number for outcome again would be number column number of outcome in your data set. My data set is the name of your data set. I called it my data, you can call it anything. And new here is the data set where the package will provide you the results in. So you can use any appropriate name you might want for your results data. And the results that the package produces include the following. The package gives you a common odds ratio of impact of treatment on outcome. It's the common odds ratio of treatment of the impact of treatment on the outcome. And the package also gives you a Mantel-Hansel p-value, which is your usual p-value to indicate whether or not it is statistically significant, which is to say if the treatment has a statistically significant effect on outcome after balancing. There is a 95% confidence interval limit, the upper bound and the lower bound. These are the 95% confidence limits. You can also have a look at the strata you created by using the following command, which is fix parentheses name of your data and close parentheses. This is a good time to pause for a moment and think, what are the other options? Confounding in observational studies has been such a major issue for such a long time that obviously stratified covariate balancing is not the only game in town when it comes to addressing this issue in observational studies. In fact, there are many older and well-known methods in terms of addressing confounding in observational studies, but they tend to be more cumbersome and require a lot of input from the analyst. Propensity score matching is one of these methods. Propensity score matching is a very well-known method, has been around for a very long time. This is basically a probability of treatment assignment which is conditional on some observed baseline characteristics. Again, it's a technique used to conduct causal analysis using data from observational studies and enables researchers to make causal statements using observational studies. How do we do propensity score matching? For propensity score matching in R, we can use another very useful R package called Match It. This was developed by Daniel Hall and colleagues. How Match It actually works. Match It selects matched samples of the original treated and control groups with similar covariate distributions. Can be used to match exactly on covariates, to match on propensity scores, or perform a variety of other matching procedures. As this introduction from author suggests, this package has some flexibility in terms of doing matching either on exactly on the covariates or matching on propensity scores or using some other method or procedure for matching. How do we use Matchit package in R? To download Matchit package in R, the command is install.packages parentheses match8 close parentheses. It must be loaded before each use, and that is one particular feature of this package, that it must be loaded before each use. And the command for that is library parentheses match8. To implement the matching procedure, which is the main procedure for this package, the command is mout match8 parentheses treatment x1 plus x2 comma data is equal to my data. Treat in this case is the dichotomized treatment variable. In this data, x1 and x2, as the name indicates, are covariates to be balanced from the data called my data, and this is just the name of the data set, my data. You can call it anything or whatever your data set is named. These were just an overview of general commands as to how we can do propensity score matching using Matchit package in R. Obviously, we discussed before, this package has multiple ways of doing the matching, and we are not going into the details of each and every step and how that works. But these commands are the basic commands. How can you download and make this package work if you are an R user? Some of the advantages of covariate balancing as compared to propensity score matching include that it not only balances covariates but all combinations of covariates through weights. Propensity score matching is often misspecified and thus leads to error. Stratified covariate balancing uses an analytical instead of a statistical approach to balancing, which is much easier and requires very little input from the analyst. This is all I had for today. Thank you very much for watching this video.